Hi, everybody. We're going to do Z3, which is add and subtract polynomials using algebra tiles. I didn't preview this one, so it'll be a surprise. Let's take a look and see what it looks like. I assume we're adding like terms. Oh, they're going to have me do the subtraction. I wonder if using the algebra tiles, I don't think they're going to let me change the subtractions to anything. No. So I wouldn't use the subtractions, but I guess we're supposed to. So here's what we're going to do. We'll go ahead and use the algebra tiles the way they're supposed to be used. So since I'm subtracting everything over here, it's literally all of these 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 are going to eliminate. I have no x's over here that are being subtracted, but I do have 4 units that are being subtracted. So now all I have to do is read my answer since I subtracted all of these. So my answer then is, let's go ahead and put it in here. Let me get rid of this dot right there. There we go. Okay, so we've got an x squared. We've got 3 x's. Oh, gotta go down to the level. There we go. Plus 3 x's, and then we've got 1, 2, 3, 4 plus 4. And that would be using algebra tiles. We're supposed to, eliminate parts. Of course, if we were doing this using our terms up here, we would use 10x squared plus 3x. Darn it. All right, fine, I'll scroll there. There, I did it. 3x plus 8. And this negative is being distributed to both of these. So I'm really adding a negative 9x squared and a negative 4. I prefer thinking of it as adding a negative rather than subtracting. With physical things, we have to, of course, subtract. But anyway, that's going to be x squared plus 3x plus 4, which is, of course, the same thing. So there you have it. I'll use the algebra tiles, though. So in this one, we're just going to collect like terms. So we're supposed to just write how many we get. I'm just going to go ahead and take a look. I've got 5 x squareds and 5 x squareds, which makes 10 x squareds. In a lot of ways, it's easier to look up here than it is to look at the tiles themselves. But there you have it. We're supposed to do it that way. So we've got 1, 2, 3, 4, 5 x's. So plus 5 x's. There are no x's on the left over here. And we've got plus 8 units, those yellow units there, because I've got 3 and then 5 more. There we have it. Okay, let's count them, shall we? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x squareds, of course. And of course, we can see that because we added the 4 with the 6. We've got, for x's, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. So, sorry, let me get rid of this. Plus 10 green x's. And I've got 7 units over here. Here's my 7 units that you can see over there. So it's plus 7. Of course, for me, it's easier to see that I'm just adding like terms, 10x plus the 7. Gotta make sure I didn't write them somewhere funky. All right. This time we're subtracting, and so I can actually do the subtraction by eliminating certain things. So these 8x squareds eliminate these 8x squareds. So they cancel each other out. These 4 x's, 1, 2, 3, 4, get rid of those 4. So now I've got 2x squared and 1x. 1 green x. It looks like I need to There we go. Okay, looks like we're adding. So I've got 7 and 2 more makes 9x squareds. We've got 6, 7, 8 x's altogether. Oh, plus, sorry. And for units, we've got 9 of them, don't we? There's 9 of them over there and none over there. Plus, oh, dang it. Did it again. There we go. Plus 7, 6, 7, 8. Yep, plus 8x. And then we have plus 9. I get a little irritated with that. That's 9x squareds plus 8x plus the 9 original. Okay, we're subtracting. So this time we're taking, and this, they have the model there. If you take 4 x's and you take away 4 x's, you get 0 x's. You don't have to write the 0, of course. And then we're taking these 2 units and subtracting off 2 of these units, which leaves you with 8 units. So it's just 8. And if you distribute, that's why it's so important to realize that that negative needs to be distributed, because we're literally subtracting them. But I did it with the tiles, so it looks good. Let's see what we got next. We are, oh, now it's kind of interesting. Subtracting negative x's is going to eliminate them, isn't it? This negative x gets eliminated. There's 3 of them that are getting eliminated. Now these 4 negatives eliminate these 4 negatives. And we end up with negative 3x squared, squared. And then we have 1, 2, 3, 4, 5, 6 x's. So it's plus 6x. And then we have minus 2 over there, 2 negative units. Now, what we want to recognize is that what's really happening, of course, is in the algebra, we are distributing this negative to both parts, aren't we? This one and that one. So that is negative 6x squared plus 6x minus 6. And I have a plus 3x squared. And I have a plus 4. There's nothing adding there. Well, look what happens. We have negative 3x squared, which is kind of what we expected here, plus the 6x that we started with, minus 2. And there it is. Let me erase it so you can see it. Same deal, either way. Distributing the negative or literally taking away negatives still works, doesn't it? It's kind of a proof of the distribution of negatives over negatives. Kind of like it. Let's see, now we're adding. So we just have 8, 9x, negative 9x squareds. It looks like we have, and I'm gonna have to count them up. Notice we're not subtracting them this time, we're adding them up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's minus, oh, dang it, I hit the submit instead of the space. God, I did this last time too. Okay, it happens. Just have to take it in stride. Okay, looks like we've got, I'm just gonna count them. We're adding them up. Let's see if I can keep from hitting the submit this time. We've got 8, 9, 10 x squareds. You know what, I'm just not gonna, 10 x squared. We've got 4 negative x's, which gives us minus 4x. I need to space it out because otherwise it'll think it's a negative. And then we've got 9, 10, 14 units plus 14 units. That's all. We're just adding stuff up. If you want, you can think of it as adding the like terms up here. We've got 10x squareds minus 4x plus 14. The 10 and the 4 add up to 14. Got to remember which one is the space and which one is the submit. All right, we've got 12. Oh, no, we don't. We are subtracting negative x squareds. So I'm going to get rid of 4 of them. There they are. I got rid of 4. And then I'm going to get rid of, it looks like 7 units. There's 7 units I'm getting rid of, and I'm getting rid of them all, which leaves me with 1, 2, 3, 4 negative x squareds. 4 of them, I said. Don't hit the submit. Negative 4 x squareds. There we go. And we've got 1, 2, 3, 4, 5, 6, 7, 8 x's plus 8x. My units got canceled out, didn't they? Because if you take 7 minus 7, you get 0, and negative 4x squared plus 8x is correct. Oh, I can't believe I did that. All right, we're subtracting. So distribute or subtract, we're literally going to cancel them out. We've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. These are going to get canceled. I've got 2 left, minus 2x. And I'm going to get rid of 2 of these negative ones, which gives me 4 negatives left. And we get negative 2x minus 4. If I were to distribute my negative, I would get, there we go, negative 10x plus 8x, which is negative 2x squared, 2x, sorry. And minus 6 plus 2 is minus 4, which is what I wrote. Okay, we're adding this time, so we have 6x squared. I think I'm just going to move right along here if I can. And we've got a lot of x's here. We've got 6, 7, 8 of them over there, and we've got 8 of them over there, which gives us 16 altogether. I cheated and looked up here to make sure. And we have a minus 5 at the end. So much easier not to use the tiles, but there you have it. Okay. I could distribute, and this equation, this expression is negative 9x plus 8 plus x minus 7. And this negative 9x plus x gives me negative 8x, and 8 minus 7 is plus 1. But what we want to recognize is that when we subtract, we're literally taking away. So I'm taking away one of these negative x's, which I did, and I'm taking away 6, 7 of these ones, units, and that gives me negative 8x plus 1. In this one, we're adding, and it looks like we've got 8, 9, 10, and 4 more makes 16, 14. It's so much easier not to count them, but there you have it. I've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 negative x's. Minus 8x, and then I've got 1, 2, 3, 4, 5, 6, 7 units. That's all. So this time we're subtracting. So I'm going to get rid of these 8. There they are. And I'm going to get rid of one of these negative x's right here. And what I'm left with is 2x squared minus 1, 2, 3, 4. Okay, I have 4 negative x's left. Darn it, it moved it on me. There we go. I've got 4 negative x's left. Oh, got to put the space. And I've got 3 negative 1s, don't I, minus 3. For me, it is so much easier to just look at my expression up here. And I've got 2x squared minus 4x minus 9. Oh, I almost missed them. See? I would have missed them. I would have gotten it wrong and would have been very upset with myself. There's 6 more of them over there. That's minus 9. So much easier. And minus space 9. How about that? So easy to make a mistake with all the pictures. Well, we're just adding them up, so this one shouldn't be too bad. 5x squared. And we've got negative 4 and negative 8x minus 8x. And it looks like that is correct based on my expression on top as well. Alrighty then. We're subtracting a negative. Now this one you really need to use the expression. You don't have to, but of course we're changing the signs of all of these and adding them, aren't we? So what subtracting all this means is really plus x squared, and we have 1, 2, 3, 4, 5, 6 x's. 6x, because this negative is saying add the opposite of those, which of course is what I'm doing here as well, which is 3x squared plus 4x plus x squared plus 6x. And we get 10x's and 4x squareds. And that is it. It's taking a lot longer because I messed up on that one. Okay, this time when you add an x squared, it's going to cancel these negative x's. Adding a positive and a negative cancel each other out. Now here's the problem. Adding an x with a negative x also cancels that out. There's some ones though that are just being added. So I have a plus 5 there. So I have 1, 2, 3, 4, 5, 6, 7 negative x squareds. And I have plus 5. And I'm just going to check my answer on the top. I've got 7x, negative 7x squared plus 5. Yep, that's it. Looks like these x's are going to cancel with these negative x's, and these 6 ones are going to cancel with 6 of these, which leaves me with 4 negatives. So I have negative 2x squareds, and I've got minus 4. There we go. Okay, we're subtracting. So for me, distributing that negative just makes all kinds of sense. We have negative 7x squared. 6x plus 6x is plus 12x. And negative 4 minus 8 is minus 12. That is so much easier. But of course, this negative right there means change the sign of everything. So these are really all negative, aren't they? And these are really all positive. This is a positive, and this is a positive, and this is a positive, and so on. And these are really all negative. If we were doing real algebra tiles, we'd literally flip them over onto the other side, wouldn't we? Because we're subtracting them. And then we're adding 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12 of them, which is my 12x. And then I've got 4 negatives with, looks like 8 more of them, which gives me a total of 12 negatives. So we get negative 7x squared plus 12, plus 12x, and then we have a minus 12. There we go. All right, we're adding like terms. We just have a single negative x squared there. And we've got a bunch of x's. We've got 10 and then 9 more makes 19. I didn't count them because I just don't feel like it. They're right there on the top. And then we've got a negative 5, but we're adding 10, so it's just plus 5. And that's just so much easier. All right, distributing the negative is going to change the signs of all of these, and then we add them. There's really no other option, and I would prefer to just do it with these. So we've got 9x squared minus 3. That's the same as plus a negative 3, by the way. That's why we can write it that way. We now have a positive 4x squared, because I distributed the negative. Sorry, that's x is kind of funky looking there. There we go. And we have a plus 7x, because we're changing the sign of all these guys. And we're also changing the sign of all those ones, which is gives us a minus 9 or plus a negative 9, because these all change their signs as well. And these are all now positive, okay? But just so you can see it. Anyway, we have 13x squareds, don't we? 13x squareds. And we have 7x, positive 7x, because all those x's change their signs. And we have a bunch of negatives. Negative 3 and negative 9 makes negative 12 altogether. And that's it. I'm just going to double check my work up here. 13x squared, yep. Plus 7x, yep. Minus 12, yep. Okay, we're just adding these up. That looks like we have 8x squareds. Oh my God, I said okay, like the guy from South Park. That's so sad. All right, it's 8x squared. 8x squared. We've got 9 x's, but we're taking away 3 of them. So we have plus 3 plus 6x. And we've got 3 negatives and 5 positives, which is plus 2. I am going to check it by adding it on the top just to make sure. We've got 8x squared right there. I've got a negative 3x plus 9x, which is plus 6x. We got a negative 3 plus 5, which is plus 2. So it looks good. Subtracting a negative gives us 8x squared. And then we're going to subtract a lot of those ones, and we're only going to have 2 left, aren't we? But we've got a lot of negative x's. We got 1, 2, 3, 4, 5, 6, 7, 8 of them. Yep. Minus 8x. Oh, got to put in a space. Darn it. There it is. And then we have, it looks like 1, 2, 3, 4, 5, 6, 7 of them. Oh no, there's 7 of them that got canceled out. There we go. So we have 2 left, plus 2. And I am going to check my work at the top. I'm going to distribute my negative and add the 4x squareds, which gives us 8x squared. I have my minus 8x doesn't change, and I have 9 minus 7 is plus 2. Yep. Don't want to make a silly error at the end here. We're subtracting 7 of them. And subtracting means changing the sign as well. So that's a positive x squared. One way to think of it is that we're adding 7x squared. We're subtracting 8x, which gives us a minus, well, let's go ahead and put it in. Let's put in our x squared first. And then we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's minus 11x. There we go. And then we're going to have 1, 2, 3, 4, 5, 6, 7, 8 negatives that change their sign. So I have 8 positives and 3 negatives makes plus 5, doesn't it? Now, of course, I should check my answer since I'm near the end. Let's see. That is wrong. Distribute that negative, and those are positive 7x squareds, which gives us 13x squared, doesn't it? Jeez. Okay, so 13x squared minus 11x plus 5 is correct. I just can't see the sense of trying to force algebra tiles into something that makes them more difficult. Now, in this particular case, we could eliminate these x squareds, which is fine, but it's just so much easier just to see what's going on up here. That's going to give us 5x squareds, of course. Our negative 10x plus 8x is negative 2x. And we can see that these 1, 2, 3, 4, 5, 6, 7, 8 x's cancel with 8 of these. There's 7 and 1 more makes 8. There they go. And we have minus 2x left. And then we have a plus 3, don't we? There we go. So we have 5x squared minus 2x and plus 3. Looks good. All right. We've got these 3 positives are canceled by these 3 negatives, and we have 1, 2, 3, 4, 5 negative x squareds left. There. I've got 1, 2, 3, 4, 5, 6 negative x's, and nothing over there being added. Was it 6? Yeah. Just gotta make sure I've actually got it right. And then I've got some positives, but I've also adding some negatives, and I have negative 4 left. So it's just minus 4. I just don't feel like doing them this much longer. 3 more, it looks like. All right, we are going to subtract 4 of these x's. There. And I'm going to have 4 left. And then I'm going to add the 3 positives, because that subtraction means that I'm really adding 3, aren't I? So that means that I've got 3, 6, 9, 10, 11, 11 ones. So let's put it in. Minus 5, 6x squared. And we've got 4x, yep, plus 4x. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus 11. And that looks like it. 2 more. I've got 1, 2, 3, 4, 5, 6, 7, 8 negative x squareds. I said 8. There. And we are adding a bunch of negative 1s to a bunch of positive 1s. So they're just going to cancel out. And of course, we can think of it as just the 7 cancels with the negative 7. We've got 8x squared plus 8x, of course. And we have one last one, and I'm just going to get her done. All right. We're going to subtract all these x squareds, which gets rid of that one, and we have 4 left, so that's minus 4x squared. And then we're subtracting all these x's, and there are 10 of them there, so it's minus 10x. And we're subtracting all of these 1's, which gives us 9 altogether, because there's negative 8 here, but I'm subtracting them, so that makes positive 8 plus 1 more makes plus 9. And just before I submit, I'm just going to check it up here. I've got negative 4x squared, and I've got a 1 and a negative 8 has to change its sign to a positive 9, and I'm changing the sign of all my x's, which makes minus 10x, doesn't it? Yep, that's it. Hope you guys, what? Okay, I'm done. I don't know what I was doing. Minus 10x plus 9. No, that's right. I got it right. Why did it count it wrong? That's so weird. I thought that's what I put. I did put it right. So anyway, hope you get yours. Hopefully it's right. I don't know. I want to check and see what I put. Did I put plus 9? Plus 9? Oh, I didn't. I thought I typed the negative and I didn't. Okay. Well, you guys get to your mastery. I'm not going to do it. It's going to drive me crazy. I'm not going to do 5 more. So bye-bye, guys.